language. The other is a matter of designing the test model. So, and then we can further go on and say that the test object 1 relates to use case 1, UC1, and the other is used to verify the requirements which is defined in a SysML model for the system test. So, and in the language specification of UTP, you see here this meta definition that the test objective specification just as an identifier to reference to it. It has a text where you put the real test objective into it. Then you can put a priority to it. Yeah? You can say this is of high importance, of lower importance, of medium importance. And you can reference a certain external standard or external model so that you can interrelate the test context to the test objectives to other specifications. So typically you find these use cases and system requirements on the system model side, and below our part the test objectives and the test context in the test model. And here I hope it starts to become clearer what we mean by system and test model. The lower part in the tester's mindset. It's about thinking what to test, write it down as a test objective, and where you get this test objective from, interrelated to the parts in the system model if you have them, and then use the test context which has the test cases which realizes these test objectives. So, then the traceability that we see once you set up such a framework is that you have the test target on the system on the test model side. You do have the test objective, which, so to say, interlinks into the test design, and then you have the test cases, which really are used to check for these test objectives. So, example 2, the requirement 2 is to be tested by the test case 2. We do that in the system model, the test model. We just, without using a test objective, we just, out of another methodology, interrelate the testing case directly to the system requirement. It also tries to depict this understanding that the testing profile doesn't pre-describe the given test methodology, but it is open to support different ways of doing systematic testing with models. And you could directly go from the system model into the test model, which is then understandable test cases. Then to the test architecture, where it's about the structure of the system on a test, what the environment, the configuration, and the deployment, how to deploy the test to the system on the test. So it's typically, if you look into the ISTQB test environment definition, it's about which software to use, which test components you have, what is the hardware, what are the simulators, adapters to emulate the system and the test components which are tested. So how to do the comparison and which databases involve all the test data needed for the test. So, and this surrounds the system under test, and all these components are typically needed for a test configuration. So sometimes you do not have simulators or hardware components, but you have test software. Often they are separated into test components and any advanced test execution frameworks also has a comparators to automatically derive the expected values receiving responses from the system test. So in UTP, with such a given test configuration, the test context is the place where you bring everything together. It has this itself, structure classifier and a behavior classifier. So the context has context behavior, test context behavior, so that you can discuss the sequence of test cases. It has operations, so that the operations becomes a set of test cases to be executed on a given test context. And it has a configuration, which says which system under test components interrelate to which test component, to which test software. So basically, for the components which can define the configuration for test context, there are the test components which assess the system under test. They bring verdict. Along test execution, they evaluate the system under test. They say pass, fail, conclusive, or error. They are used to evaluate the system under test, and the system under test can also consist of several components, SUT components, so that we can have a composite of SUT components which are tested. And then there is another important component on the test context side, which is an arbiter, to arbitrate the test results. Do you have any idea of arbitration? Well, think about functional testing. A tester checks for the different functions of the system under test. There you would like, I guess, to see whenever there is an error, this isn't superseded. Whenever some test component says fail, the overall result should likewise be fail. So we call it functional test arbitration, or the only get worse rule. So one says no, then everything turns no. This is perfect arbitration for functional testing. It's less perfect for performance testing. Do you know why? So why I'd like to see another arbitration scheme for performance testing?
Because performance testing requires you to rely on time behavior
As well? Yes.
and also resource utilization.
Yes.
The container doesn't require those two.
Yes. And I would say in performance testing, it's also it's a robustness stability testing. You would be ready to ignore certain failures of the system as long as the overall performance is okay. Yeah, you rather think in 5 nines, right? Or you think in 95% of the cases the system should respond correctly. I can accept 5% failures because of high load or overload situations. Yeah? In such a situation, you do need another arbitration scheme. Yes? So there, it should be tolerated that certain test components return with a fail verdict. And that's why the testing profile supports there the arbitration. Yeah? A test context can say, this is a functional test context, or this is a performance test context, or this is an interoperability test context, or a security test context. And depending on the test context, the evaluation of the test results can change. Every test component has its own verdict. They contribute to the verdict of the test context. And the test context uses the arbitration to compute the overall result. Okay? So meaning you can have the very same test context, but with a different arbiter, you typically would get other test results because you put on another evaluation scheme. And again, this depends on the purpose of the test, what you want to evaluate, and then the arbiter defines how you evaluate. Okay, so to sum it up, the test components are the drivers for the test case behavior. They are under full control of the test execution system. They stimulate the system under test and evaluate the responses from the system under test. The SUT components, they constitute the SUT. So it could be not just one component, but several interconnected components which contribute to this test configuration. And they are interconnected to the test components, but also to other SUT components. They just define the test, the system under test. And then the test context, that is, so to say, the root for all the test definitions. So it defines the test environment, test configuration, test suite as a collection of test cases, and the behavior of the test context is the test execution plan, how to execute which test case with which parameters and so on.